I'm audible properly.
Yes, sir. Yes.
Uh, First of all, I just thank and welcome all who are present here. I also thank Vice Chancellor IIMT to organize this kind of event and all the coordinators, all the deans, all the head of the departments. And I also congratulate the team that is organizing this particular EP. Your FDP is on Industry 5, opportunities and challenges. That is the topic of demand. So I'm going to present this cloud computing aspect in a nutshell with an idea that uh, you are you asked me to introduce this on an elementary level, and the time was somewhere around 1 hour. So it's a huge topic that is very hard to bundle up in 1.5 hours. But since this is an introduction kind of thing, I will try to touch up whatever maximum I can. So you please let me know at the point where I need to stop. So because the things can continue on, I will try to keep myself within the limits of time frame that I have. For this, if you just permit, we can start with the cloud computing aspect. Should we go? Hello.
Vishal sir, you please proceed. But it is my request to please open your camera. Vishal sir.
My camera is open, I think. Why not? It is not. It is not.
It is not open.
It is not opening up. I don't know. Just see. Now it is open.
Now it is okay. Now it is okay, Vishal sir. Please.
Right, right. Let me. Mm, I think so. It is opening up.
Yes, sir.
Yes, sir.
Uh, this will probably. So, yeah. We started with Industry 4 that was highly on automation with the help of robotics and all. But when we move on to Industry 5.0, it is towards automation. This automation is towards personal automation. And for this, there are few technologies that are in currently in high demand. And these are big data and artificial intelligence, IoT. And when we are building up so much of this data, no doubt we want a huge space, huge computing power, and so on and so forth. That is virtually boundless. And to keep this requirement in hand or in mind, we have this concept that is known as cloud computing. So my idea of this presentation will be like this, that I will try to introduce you cloud computing with a certain aspects as coined by certain industries or certain academia. Then we will go for what are the market trends as far as this cloud computing is concerned? What is the market proposition of this cloud computing? Us? What are the architecture models as far as NIST, as far as cloud computing is concerned? And then I will just say a certain limitation for this, and I will also try to give you certain references so that you can build upon this topic more as per your interest. So with this a brief guideline, I will start my presentation for you all. So let's have this. First of all, go for the introduction, and this is what is cloud computing. So over here, I have compiled the definition of cloud computing as quoted by the different resources as available in the literature, and we'll see what are all these things. So if we go for the definition of cloud computing by Investopedia, it says that cloud computing is the delivery of different services through the internet. These resources include tools and applications like data storage, servers, databases, networking, and software. So whatever IT infrastructure is there, that can be provisioned with the help of cloud computing. And over here, the punch is through the internet. Means uh, we access this cloud computing technology with the help of internet. So this is the takeaway as far as this Investopedia is concerned. Moving ahead with the definition of what we have of Cloudpedia on Wikipedia, it says that it is a on-demand availability of different computing resources, right? It's a on-demand availability. Means we can provision the resources. The resources can be of any type. This is of compute. This is of storage or anyone. And this is provisioned with and when we require it. So this is a on-demand availability of these resources. Next up, the definition from Java Found. Java Find, a very, very common website that is used by the academia just to reference certain material. I also gone through this and pick up this definition just to share with you all. This is that this is the practice of using a network of remote servers hosted on the internet to store, manage, and process data rather than a local server or personal computer. Means the resources are away from the user, and these are used with the help of the network that I said earlier as well. This is through the internet. The takeaway is cloud computing is a virtualization based technology. This is this virtualization that makes the cloud computing just to have this in the way that it has come to us. So this is the virtualization, and this is the technology, the concept behind cloud computing. So we'll just look into it a bit, whatever the time permits. Next is the definition from the industry. This is from IBM. This is that it is somewhat, you can see the repeated part, so I'm not touching that part. And the part that is interesting is this is hosted by a remote data center managed by cloud service provider. So we come up with this notion of cloud service provider. Basically, these are the service provider or for cloud computing services. So anyone who is interested to go with this kind of technology and approach can touch up with this CSP and can provision the resources as per the requirement and different models that will be see shortly. The cloud service provider makes these resources available because this is a business and business means money. So customer are charged and CSP make money out of this charge. And this charge is either on the monthly subscription fee or it is pay per use kind of model they can adopt. This whatever you use, you bill them, company or the CSP will bill them accordingly, and after accordingly they will pay the uses that they have done. If we go for Amazon, Amazon takeaways as a needed basis. As needed basis means it says that you don't need to think or design whatever kind of resources you require beforehand. Means you start with something that you have. As you proceed, the requirement may increase. As the requirement increase, you can ask for more resources from the cloud service provider. So what is that? Uh, Whatever resources that are provisioned in cloud computing, they can be put in as needed basis. So you don't need to put them in a single go. As a need arises, you can scale up or scale down whatever resources that required to run the organization. Lastly, I will come up with this standard, the NIST definition for cloud computing. And as this is a standard, National Institute of Standards and Technology, it has come up with with this definition, and it invariably encompasses all the features of the cloud computing uh, concept or aspect that is there in the uh, field. And this says that cloud computing is a model for enabling ubiquitous. Ubiquitous means anywhere, anytime, anywhere kind of scenario is there. It is convenient in the sense that can be accessed. The resources that are provisioned can be accessed by by means of an heterogeneous set of resources. Say it can be mobile, it can be desktop, it can be a laptop or whatever media you can use, or whatever not media, it is whatever device you are using. It is an on-demand network. Means the services are provisioned as and when demanded. Network access means it is accessed by means of an internet to a shared pool. Shared pool means that it is basically based on the concept of virtualization that gives you a notion that each individual is working on her or his own set of hardware devices on different resources of the net. But in fact, all of these resources are shared. And we have the notion of multi-tenant as far as cloud computing is concerned. So I will see at the time comes what is multi-tenancy means. Uh, to a shared pool of configurable computing resources, network servers, storage, application, and services that can be rapidly provisioned and released. So, means since this is on demand basis, the resources that are demanded and provisioned, they can be either scale up or scale down as and when there is a requirement from the industry with minimal management of another feature of it that it is a minimal management effort or service provider interaction. This is another beauty as far as cloud computing is concerned. So if we just look into this definition given by NST, it basically comprise of all the features and advantages as far as cloud computing model is concerned. I hope I'm audible to all. Looking into this, that's a pictorial view. So, what is a cloud computing metaphor? It's what you say that you are having applications, platform, infrastructure, or are in the form of cloud, and the user is interacting with this cloud with by means of servers, laptops, phones, tablets, and desktop and all. So, this is what we have discussed before. NIST, if we talk about NIST, NIST gives five essential characteristics as far as cloud computing is concerned. So let's have a look on today's characteristics one by one. It is an on-demand service, means that a customer can unilaterally provision computing capabilities. Unilaterally means it is by the choice of the user to provision these services, and that user, if it is required to scale up or scale down, he can do it. But of course there are certain agreements are there, but as such the philosophy says that these resources are provisioned on a demand basis, right? Broad network access, this particular says that capabilities are available over the internet and access by means of internet by using different kind of clients that I told you, that left mobile or whatever. Resource pooling. It says that the provider's computing resources are pooled to serve multiple consumers using multi-tenant model. Multi-tenant model means a number of its same hardware, since it is very computational rich, it is partitioned by means of virtualization in a number of parts, and each part is given to different customer or user, giving a feel that the user is working on a dedicated set of infrastructure. So this is outcome is a same piece of hardware can be used by a number of users, and this particular notion of usage is known as multi-tenant facility, right? And this is possible just because of the concept of virtualization, right? Uh, with this is also gives the notion of location independence, means the user asks for resources, but where this resource is, it is not their cup of tea. They are found, they ask certain resource, it is provision to them, right? But they cannot particularly ask for which particular resource they want, right? But there is certain variation into it, means they can customize a bit part of it to the that they can ask for certain country, state, or to the certain extent to a particular data center. Means we want a resource from this, but again, this is all dependent upon the kind of agreements that are built up between the customer and the service providers. Rapid elasticity. This says that capabilities that are asked can be elastically provisioned and released. This is a notion of scaling up and scaling down. And this is the cloud computing architecture. This gives very much flexibility to it. Metered service. There is a notion of how the services are charged. This is a service-oriented model. Cloud computing model is a service-oriented model, and every service as normal utility is charged. So this is also charged, and there are different models of this meter service. Either you pay as much as you use, or you can go for a monthly subscription kind of billing architecture, and so on and so forth. So these are certain characteristics that are defined and given by NIST. If we go for the history of cloud computing, is from where this cloud computing concept came. So just to revert back, we were having simple machines. After that simple machines, there was the concept of time server computing kind of model in which we were having a strong client and a number of low capability machines known as client were using the computing power of this client server model. And then became the concept of distributed computing. Distributed computing means the machines are now fixed to a particular location, then be distributed far areas as far as the industry offices or department are concerned. Then came the concept of cloud computing, and this cloud computing is again built up on the concept of distributed computing, but it is somewhat adding this feature that we know as location independency to this distributing nature of this computing, giving rise to this cloud computing. Just to get certain more facts, let's have a look into this. We look into this somewhere around 1961. This person, John McCarthy, he suggested that like other things that we have in life, like water, electricity that we use as utility, and they are built as per our usage. Same way, the computing devices or computing can be used as a service, and yeah, Anish.
Hello.
Uh,
Yes, sir. Actually, sir, screen is not uh, changing.
यार ऐसे कैसे पॉसिबल है
Slide.
ऐसे कैसे
Actually, I
पॉसिबल
can see
है
only one slide, that is cloud computing. That is your first slide.
okay I just start one more time
Now it is visible. History
now
of cloud computing.
I pass on to this now. Do you see this?
History of cloud computing.
uh, can you read out whatever is written beneath this history of cloud computing at around 1961? Do you see?
You sir start it on the top menu bar.
uh, on the top menu bar. Everything is there. I don't know why it is so. I should go and this. Why is this so? अब दिखा है? अब दिख रहा है? अतुल जी?
अभी तो सर it is only showing history of cloud computing slide.
Now certain data is
Same
coming
sir.
or not?
No sir.
ऐसा क्यों हो रहा है? डेटा क्यों आ रहा है? हम्म, डेटा क्यों नहीं आ रहा? ये दिखाई देता है? ये दिखाई दे रहा है?
No sir.
अरे
I can see and rest of the slides left side.
ऐसा हो रहा है, नहीं समझ पा रहे. अब भी नहीं दिखाई दे रहा.
No.
So give me a minute. I'm just changing this PDF. I will try to share that one, right? Give me.
Okay sir.
Now let me know. Are you able to see? Hello? Are you able to see now? Hello?
Hello.
हेलो. हाँ
Yes
सर,
sir.
आप दिख रहा है?
हाँ.
ये सब दिख रहा है सर आपको?
Yeah, definition of cloud computing. Yes.
राइट. तो मैं स्पीच तक आज का आपने मुझे पहले टोक देते हैं, तो शायद कुछ पीपीटी में कुछ नेटवर्क इशू कर रहा है. सो
Okay.
कोई बात नहीं, हम इसको पीडीएफ पे कोशिश करते हैं, राइट?
Okay.
सो इज दिस स्लाइड विजिबल टू यू ऑल?
Yes sir.
I was talking about this history. I was telling that this is the idea. That's where the computing resources can be used as an utility and can be charged as we pay for water and electricity. Idea was suggested by John McCarthy in 1961, and as with the brilliant ideas that we have seen from the history, this idea was far ahead of time, and nobody took this very seriously. And this was just put in on the racks. But this was a brilliant idea, and after certain improvement, advancement in technology, that idea came into a reality, and this reality is cloud computing, where the different services of computing, storage, softwares can be used as a service and charged as per their usage. Just to add up this, in 1999, Salesforce.com started delivering application using a simple website, and this was an idea. This was an idea and a realization of the dream that was seen by the John McCarthy. In 2002, Amazon started Amazon Web Services, but it was actually in 2006 with the with the delivery of Amazon EC2, the actual open market and commercialized version of this Amazon cloud services were open to the community. In 2009, Google Apps started providing computing enterprise applications. In 2009, Microsoft launched Microsoft Azure. And since this was a hot cake, no company wanted to stay behind. So other companies like Oracle, HP, they are all in that game. This is the potential of or the hope as far as cloud computing is concerned. So with this, if we want to conclude with this in a short gap, this is that cloud computing is now a mainstream, right? So it is listing a few cloud service provider. So almost every player is in this field and they are providing cloud services to the customers, be it Amazon, it comes under the name Amazon Web Services. With Microsoft, we are having Microsoft Azure. With Google, we are having Google Cloud Platform, IBM Cloud Services, Ocean, and so on and so forth. So this is the market and potential. This is certain stats that I'd like to share with you all. But because every industry is a commercial world, every work is not balanced by means of the money it turns out. So just see what is the scope and how the companies are putting their money into it. According to this report by International Data Corporation, global spending on cloud computing services has reached $2,706 billion and expected to grow more. And it is expected to grow by $1.3 trillion by 2025. Gartner, the very well known as far as the computer world is concerned, he forecasted for 2022 that this industry of cloud computing, particularly public cloud computing, will reach nearly 500 billion by the year 2022, and that is expected to rise further for 600 by the year 2023. McKinsey and Company reported that cloud cost optimization levers and value-oriented business use cases foresee more than $1 trillion in that EBITDA across Fortune 500 companies. And this is up for grabs for up to year 2030. In 22, Gartner also proposed that or visualized that more than $1.3 trillion in enterprise IT spending was at stake for migration to the cloud technology. And this is growing almost on a very fast rate. And this is figure for as defined by Gartner, it is $1.8 trillion by the year of 2025. So that is in a slide just to make you, just to show you that there is a strong adaptation and inclination towards this technology, and nearly all of the companies that we have, they are running to adopt this kind of technology, and the spending is very huge. And this is, as you can see, with the help of this data that is there on the screen. So this is a very promising technology. As far as benefits, just to count a number that you have already seen, a number of things I will try to continue more. Agility. Agility says that cloud gives you the easy access to a broad range of computing technologies so that you can innovate faster and build nearly anything that you can imagine. This is the agility that cloud computing provides. You can quickly spin up resources and leave them when you are done with them. So this is agility. Increase productivity. You can deploy tech services in a matter of seconds and get from the ideas implemented several orders of magnitude faster than before, right? Because you are having very efficient and fast processing computational infrastructure in your disposal, and you can results that are very fast. Cost saving, because over here you don't think about the capex. CapEx is the capital expenditure. So what do you think of? You think just on your application as far as resources are concerned, you don't need to pay for that resources in advance. Only thing is, just think of the application, just think of what kind of infrastructure is adequate for this, and then you go for renting them from the cloud, right? And cloud service providers are there just to satisfy your request. So this is just handles your capex. Only thing is you have to manage the OPEX properly. By OPEX, I hope you all understand. OPEX means operational cost because this is a metered service. So users point of view, you have to just think in the improved security. That is, cloud offers many advanced features related to security, and this ensures that data in cloud is securely handled and stored. Scalability and flexibility. If you just count this, this is basically cloud is a on-demand facility where resources are provisioned as and when demanded. This gives you a great flexibility, meaning that with cloud, you don't need to over provision resources upfront to handle peak levels. Yes, as the demand increases, you can increase your contract for resources. You can have these resources at your disposal and then required by the market. Better collaboration. This improves collaborations by allowing groups of people to quickly and easily share information in the cloud via means of shared storage. Deploy. Then it is enhanced customer experience. It is something that the services of cloud can be utilized and used by means of a heterogeneous set of devices, be it mobile, be it laptop, whatever. So customer can customer can use these services as per its convenience, right? So it gives you an enhanced customer experience. Uh, Disaster recovery is something that is associated with the and restore. So once you have stored your data in the cloud, it is easier to back up and restore that data using the cloud. So this gives you better chance in case of a disaster. Along with this, we also have certain advantages that are not mentioned on here. Just to recall those, these are deploy globally in minutes with the cloud. You can expand to new geographical regions and deploy globally in minutes, right? So there is again another advantage. Excellent accessibility because the services of cloud are ubiquitous in nature. That says that you can use the services of cloud anywhere, anytime, and by any means, right? Low maintenance cost. This particular thing is so this particular feature of cloud computing says that this cloud computing model reduces both hardware and software maintenance because you don't own it, so you are not bothered to maintain it. It is the job cloud service provider to maintain that. So as far as end user is concerned, there is virtually no maintenance cost as far as cloud computing model is concerned. Now the question is, if the cloud computing is so promising, what are the different players who are using this cloud computing? Right. So we can summarize that organizations of every type, size, and industry are using this cloud services for variety of use cases. Just to have that, these are the different fields, basically, different applications in which cloud services are used. I will try to just give you an idea of what are the different cloud services that are used, just to pick up the lost time that we had in the start of this session. So if we just talk about applications, we have Move, Vista Print, and Adobe Creative Cloud. If I talk about this particular Adobe Creative Cloud, this is the bundle of services, and that is there. That's to design attractive cards, booklets, and images, and all sort of things that we require as far as art applications are concerned. If we talk about the business applications, we have MailChimp, Salesforce, Chatter, Bittix, PayPal, Slack, QuickBooks. Some of you already, I hope you already know, Salesforce is generally used for marketing kind of things, whether it's for sales, services, marketing, and e-commerce. If you just PayPal of Venezuela, and this is a quickest, basically one of the quickest online payment mode of. Uh, if you talk about data storage and backup application, we have Box.com, Mozy, YouTube, Google G. Google's G Suite once again, the very familiar and most heavily used cloud services. It is bundling up with not only storage, with also many other services like calendar, docs, spreadsheets, and so on and so forth. So it's a bundle of applications that you have as far as Google G Cloud Suite is concerned. As far as education is concerned, so you have Google Apps for education, Chromebooks for education, AWS and education, and one of the very, very fascinating and most commonly used Google app for education was classrooms that we have all seen during the pandemic times. We just talk about the entertainment applications. So these are on the category of online games and video conferencing apps. One of that we are already using right now, that is Zoom facility. This is one of the cloud computing based facility for video conferencing. We know. Likewise, we are having many other facility for video conferencing. Online games, pandemic was on. When pandemic was on, the kids, not only kids, the elders were all confined to the boundaries of their homes, rather rooms. So this field of online games took the pace, and what we are all agree to that this kind of pace that started with the pandemic is not going to live very very soon. So we are having a number of online game facilities that are basically based on clouds, and the people are enjoying them. We talk about the management applications. We are having Toggle, Evernote, Outright, GoToMeeting, Evernote. Just to take as an example, Evernote is kind of service, cloud service that manages a number kind of variety of notes. This is audio notes, written notes, or textual notes. They are number, they can collect and summarize all those notes. So again, apps. If we talk about social application as far as cloud computing services are concerned, so these are all very familiar. The Facebook, the Twitter, the LinkedIn, the Yammer, these are all facilities that are using the cloud computing. No doubt, WhatsApp message. Now, having this notion of cloud computing in hand, but we know that is very promising technology that is used virtually by all, not only by industry but also by the end user. So having this positivity in our mind, let's see somewhat in a small note as far as architecture is concerned. So if I talk about NIST came up with this white note on this that gave the definition that we have shared earlier. It gave five essential characteristics that we have seen. It came up with two kinds of model of services. One is the model of services, and one is a model of deployment. So there are three kind of service models and four kind of deployment models as far as cloud computing architecture is concerned. And let's see those things in a brief. Yeah, cloud computing models. And now we are taking first on the direction of service. So this is the service model. Three service models are provisioned as far as cloud is concerned. One is software as a service. So in cloud computing model, everything is a service, and these services are metered service used as an utility. So software as a service, it is a service that provides with a complete product that is run and managed by the cloud service provider, right? And this particular cloud SaaS is accessed by a web browser, a dedicated desktop client, or an API. With SaaS offering, you don't need to think about how the service is maintained or how the underlying infrastructure is managed. You only need to think about how you will see that particular piece of software. So the managerial kind of botheration, you are free from it. Just to quote certain example for this kind of services, we have Google Apps, Salesforce, Dropbox, Slack, HubSpot, Cisco Direct. Next in line is platform as a service, right? So we are decreasing from the level of abstraction. Means SaaS is on the highest level of abstraction. Platform as a service is on the middle level of abstraction. This service, a platform as a service, provides software developers with on-demand platform. And this platform is hardware, software, or other infrastructure, right? That is used for running, developing, and managing applications, right? Once again, it removes the need to manage the underlying infrastructure. Usually, this infrastructure is the hardware and the operating system, and this allows you to focus on the deployment and management of your application. Thereby, this is more efficient in a sense that you need to worry about resource procurement, capacity building, and so on and so forth, because this all is taken care of by this platform as a service. Just to count certain example, this is Windows Azure, Host.com, Magneto Commerce Cloud, OpenShift. These are all examples of PaaS. This is the last type of service that is infrastructure as a service. Yes. As far as abstraction is concerned, this is on the lowest level of abstraction, right? And this is what? This is a service that provides on-demand access to fundamental computing resources over the internet on a pay-as-you-go basis, right? This enables end users to scale and shrink down the resources as and when there is a need for it, right? It may be owned, managed, or operated by a business, academia, or government, or it provides with the highest level of flexibility and management control over your IT resources. So if you just compare this, means you are having the highest flexibility, means you can you can customize the resources as per your wish, but it requires effort. It requires effort, and this requires a managerial control over the IT resources that you have just procured. Means you have got agreement with. This was not the case with the earlier services like SaaS and PaaS, where everything was managed by the cloud service provider. But the issue was, the negative was that you were given this other service. Only thing you can do is use it. You cannot customize that. But over here, you are having a customization control. But again, you have to put effort to managerial aspect, right? And if you compare this with this IT resources that you know in the current scenario, if you are not learned that today, so this is a kind of service that is most similarly, no, 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 put as far with the IT resources that are existing right now. We just have certain example for this kind of service. These are Amazon Web Service, EC2, Elastic Compute Cloud, Google Computing Engine, and Cisco Meta Cloud. So these are the three different services that are provisioned as far as cloud REST is concerned. If we just look into the cloud computing model from the point of view of deployment, there are four models to it as coined by NIST. One is public cloud. Public cloud is provision for open use by the general public, and this the cloud is used by used internet. The public cloud provider can provide the usage of this cloud or for free, or they can be charged. The services on the public cloud can be charged on a subscription based or paper pricing use by paper you per pay per usage model. Public clouds are owned, managed, and operated by a business, academia, or government organization, and maybe it can be a certain combination of them as such. Exists on the premises of cloud provider and supports maintenance environment. And examples are Amazon Web Services, Google Cloud, IBM Cloud, Azure, and Oracle Cloud. Yes, Dr. Ratul, there is something to say, I think. How
No,
much
sir, please
time?
continue. No, sir, please
Uh,
continue.
how, how much time do we have for this session?
Sir, we have time. You can uh, cover the related topics. We have time.
Okay. Okay.
Although the time is up to 9:30 to 10:30, but we can spare more time.
Actually, I was told that it is from 9 to 10, so or 9:15 to 10:15. Again, okay, I will try to finish this up as soon as possible because I need to leave to my office, right? So,
Yeah, okay,
I
okay,
will
sir,
be,
definitely.
I will be just for this, right?
Okay, sir, okay, okay.
Uh, Private cloud, as the name suggests, it is provision for exclusive use by a single organization. We just call private cloud with different names as internal cloud or corporate cloud as well, due to the characteristic that it has. It is owned, managed, and operated by the organization, a third party, or some combination of them, right? Private cloud. So, what is that private cloud provides to you is, along with all the facilities that a cloud provision, along with that, it also provides the other benefits such as access control, security, and resource customization of on-premises infrastructure. So private means a sense of ownership, exclusive ownership is concerned, and this particular deployment model is just to realize that reality. It may exist on or off premises. So physical location is not an issue. Issue is how this is used, right? As far as public cloud is concerned, so public cloud, oh sorry, as far as the private cloud is concerned, since this is a private, we have to have a number of managerial aspects into it. So it is somewhat a burden as far as cloud computing services are concerned, but it gives you more control on your infrastructure, on your data, and so on and so forth. So just to take along with this private cloud, what we have that private cloud is something that is managed by the private organization. So it comes with number of services. First of all, you have to have certain services that realize that virtual machine, right? And then you have certain services that, with the help of which you go for the realization of you go for the realization of management of these virtual machines. So uh, we are having a number of aspects into this. There are different services for it. I want to take you to a particular service that is very, very commonly used, and that is Aneka. Aneka is a SaaS means it provides you software as a service on private cloud. Aneka is a SaaS kind of provisioning facility that you can have as far as private cloud is concerned, and this way we can go on, right? So just to give an idea in this short span of time that is given to me, right? I hope you must have heard Aneka. And on Aneka, if you want to have this introductory note, there is a very good book of Rajkumar Bua by McGraw-Hill, and the name of the book is Mastering Cloud Computing. You can have this introductory part of Aneka on this book. Hybrid cloud, as the name suggests, hybrid cloud is something. Hybrid cloud is something that is composed of a mix of public and private. Idea is to use the advantages of both of these two models of private cloud as well as hybrid cloud. And the downfall is, but of course, since this is the mix, this mix comes up with certain complexities on the management side, right? Community cloud, this is the another kind of deployment model, and it is provision for exclusive use by a specific community of consumers that have shared tools. As far as owning, management, and operated is concerned, it is can be operated by one or more of the organization. It may exist on or off the premises. Community cloud can be compared with the public cloud with the contrast that it is used just like a public cloud, but it is limited to a certain set of people where the people are the people are working towards a certain goal of community, be it NGO, maybe healthcare or whatever it is. But public cloud is open for all, right? So with the public cloud, what we see that just for a note of comparison, virtually we are having no limit on the users as far as public cloud is concerned. But when it is a community cloud, it behaves like a public cloud. But over here, the number of users that can be hooked into this cloud are limited, and this number is very well authenticated and authorized. So it is with this, I just come up with the discussion of the different models for deployment and services as far as cloud is concerned. Now, as I told you earlier, that this is the concept of virtualization that has made this cloud computing concept a reality. So, what virtualization means? Virtualization permits the formation of an intellectual abstraction layer. What does layer does? This layer takes all the complexities of the original hardware and software and provides you whatever you are interested in. It is a concept that gives you sense of exclusiveness on a shared resources that are actually there physically in the cloud computing environment, right? So this virtualization gives rise to create a number of virtual machines, as the name specifies. Virtual machine is a virtual interpretation or representation or an emulation of a physical computer, right? So a virtual machine that the virtualization create, this cannot interact directly with a physical computer. So we require something in between, and this something is known as hypervisor as far as cloud computing paradigm is concerned. This is this hypervisor that allocates the different physical computing resources to different virtual models, virtual machines it maintains. It is the responsibility of this hypervisor to keep the different virtual machines that it has created and managed in such a way that they are not interfering. Means there is no data breach as far as virtual machines are concerned. So this is the responsibility of hypervisor. We also term hypervisor with certain different names as such. As far as literature is concerned, this is virtual server instances or virtual private server. Just to confirm what it does, we just to have a bit idea of how this virtualization works. So this is that this is virtualization. This create virtual machines, and when these machines are created, these machines can run their own operating system and application independently. Means the different virtual machines that are created behave as if that they are independent entity, and whatever communication or sharing of the original resources of the bare metal machine is concerned, it is managed by the hypervisor, right? So, to conclude, we can say that the hypervisor acts as a traffic cop of sorts, directing and allocating the bare metal's resources to each of the various virtual machines it creates. And it also ensures that they don't disturb each other, right? So this is the aspect or responsibility of hypervisor. We find two kinds of hypervisors, type 1 hypervisors and type 2 hypervisors. So interested person can look into that. Uh, One is to the level of physical hardware and one is to the level of next category, that is not only hardware but on the level of operating system. Friends, this slide just gives a notion, means why we should go for a study, a research, a course as far as cloud computing is concerned, because the trends show that the market is on as far as cloud computing is concerned. So just to read this out from this varieties.com, it says that the cloud computing is a technology, is a paradigm that is going to remain for future to come, because it gives so many advantages and it is not all done yet. We are having so many scope in which we can research, we can add value to this cloud computing company. So just to have that, increase multi-cloud integration. So since cloud are provisioned by different players, so there is always a challenge, uh, if there is a need, and always there is a need for multi-cloud kind of paradigms. We are not dependent upon a single cloud. Generally, people or organizations buy resources or services from multiple clouds, so giving rise to the multi-cloud model. And there are issues this multi-cloud integration kind of scenario. So there are challenges, and researchers are finding ways to come up come up with these challenges, because the need is there for increased multi-cloud integration, and there is a scope of research into this. All right. Better security, since everything is there on the cloud, nothing is there on the hand or within the premises as far as user is concerned. Data is there on the cloud. So whatever provisioning of services, we can hope hackers are far way ahead as far as technology is concerned. So there is always a continuum effort to make or save the data and resources from the breach. And always this gives you a promising line of research as far as security in cloud computing is concerned. Uh, just to cut short, I will take certain things more. Gaming spirit high again. This is a post and pandemic effort. Philosophy gaming was high. I think no need to explain it more. Uh, Decline of latencies again, huge challenge. This is the issue that is concerned with the different kind of routes as far as cloud computing model is concerned. Research is also there in this field. Latency says that since your data is somewhere else, your computing resources somewhere else, and you are somewhere else. So to realize certain goal, these three people, you, your data, the accompanying devices, are hooked in with the help of network, and network takes time. So we need certain policies where this kind of no, time, whether this is from you to data center to network computational facilities to back to you, and so on and so forth, can be reduced. So research and new algorithms are always coming now and then to reduce this latency. Lower the latency, more is the response time, and always there is a big push as far as response time is concerned. Artificial intelligence and machine learning. We are having bulk of data that is consumed on cloud computing, that I started in the earlier opening remark, that we are capturing data on very fast rate. To have this data accommodate, we need virtually limitless capacity, and that is there with the cloud computing scenario. But data is a pacifier. To give a real meaning to it, we need something to process and take the outcomes from this. And this is where the artificial intelligence and machine learning approach come. Uh, Along with this, there is one more thing, that is big data analytics. So big data analytics makes use of this data that is virtually used and that is characterized by 5 Vs. And with the help of this big data techniques, that is mixed of machine learning and artificial intelligence, we come up with the uh, positive conclusion of the data that we have just received and stored in our cloud. Edge computing, again, this is something that is a hot cake as far as cloud computing is concerned. It is something that is there towards the edge of the network. So again, this is an effort to reduce down latencies to give you the result very soon, to optimize that response time, right? Plus, we have this Kubernetes and Docker. So this is something I will please spend more time with. Uh, just have a look on this. So I hope I have slides for that. So Kubernetes with थोड़ा सा बात करते हैं. Can we talk for certain time? Few minutes more?
Yes, sir.
Can we talk few minutes more? Should I bundle this up?
Yes, sir. You can take few minutes more.
Okay. Kubernetes लास्ट पॉइंट है, थोड़ा सा हाइप है, और क्लाउड कंप्यूटिंग में बात करते हैं तो प्लस का टच जरूरी है. तो
Yes, sir.
क्यूबरनेट तो थोड़ा सा इसके लिए बात करते हैं जरा सा, हाँ? थोड़ा सा स्पॉइल लेंगे बस. Uh, this is an idea that earlier we were having monolithic applications, means whatever applications were there, there were number of parts of it, and every part was intermingled. So this was not independent, but with monolithic application transition to microservices, what happened that all of these services were known as separated, and then comes with the concept of Docker, right? So anyone who is familiar with the container kind of thing must be knowing this Docker, because this Docker technology, if I'm not wrong, then it is its share is 95% or more than 95% as far as container facility is concerned. So Docker is something that create containers, and container is, it is a bundled unit for all the dependencies libraries with the app microservice, so that it can virtually run on any of the machines, because it is not dependent. It is whatever things it is dependent upon, it is taking them all togetherly. So then comes the Kubernetes. So Kubernetes is something that is not taken as what we should say, it's not taken as a alternate to Docker. Rather, these two technologies go hand in hand. This is that Docker is something that is used to create the containers, and Kubernetes is something that is used to manage the uh, container, right? So, what is that? If you want to realize cloud services, you have to deploy them. And Kubernetes is something that is open source that is used to help you out to deploy those services, the cloud services, as far as your application is concerned. And it is one thing that is very important, that to use Kubernetes, you have to have your application converted into the microservices. So microservices are very important in a sense. From microservices, you convert to Dockers. Rather, Docker is a proprietary, and we should use containers. And from the containers, we go for the Kubernetes to deploy them on the cloud. This is the Kubernetes architecture diagram. So the elementary unit, if you see, this is this pod, right? Pod is something that contains one or more containers, right? Uh, the containers that the pod has use resources and they can communicate with each other or to other nodes. Every pod has got its unique ID so that it can be addressed to. Then come concept of node. There are two types of nodes as far as Kubernetes architecture is concerned. One is the master node and the other one is the worker node. So from this, you can just make it out. It uses a client master slave kind of philosophy or client server kind of philosophy, right? Next is cluster. This is the cluster. This cluster is again combination of master nodes and worker nodes with the requirement that every cluster should have at least one of the master node, right? And the cluster is an entity that actually runs the containerized application that are managed by the Kubernetes. So you just look into this worker nodes, there are certain parts of it. So kubelet is something that listens to the master node and direct the working of the worker nodes. Uh, Network proxies are basically used for setting up IP tables through which they are addressed by the network. Master nodes, very important component apart from other is the key value store. This is the configuration details as far as Kubernetes is concerned, and this is very important and this is very crucial. So the philosophy says that since this is very crucial, we should have the replicas of it in the node, and then we are having a scheduler. Scheduler is something that is that makes a pod run when it is or when it is a chance of this node to run. When we have what controller works to move the application from its current state towards the desired final state. API server is kind of communication paradigm that is communicated by the developer and it is used received by the different components. Rather, this is worker node or this is master node with the help of this different APIs. So to manage different APIs, we are having API server and so forth in the case of Kubernetes. So just to make this short, I am just not going to further details as far as Kubernetes is concerned. So let me bypass this. Last but not least, with every technology, there are certain limitations, and we should not ignore them. There are certain things that come with the heading as limitation. There are certain things that come with the disadvantages. Limitation is opening remark was that it is a service that is used by the internet. So everything is dependent upon the internet. If internet is down, you are of no help. Plus, you cannot access cloud services. So internet connectivity, a persistent internet connectivity is a big limitation or big challenge that you need to have as far as you want to have a cloud service facility, Vendor lock-in. There are a number of cloud service provider, and each one of them is having its own specific constraints or features or deployment or design. So if you are going for a multi-client kind of scenario, there is an increase in demand. So it becomes very cumbersome. So somehow the customer feels that I am stuck into a particular vendor. That's why I said that trend is going for increased multi-cloud kind of scenario. That's how we can take the dissimilarities of different clouds and come up with a solution so that the different clouds can be used in a homogeneous way. Limit control. Since the resources are outsourced, so there is a limited control as far as these resources are concerned because these resources are managed. So one way it is a facility because you are concerned with your application, but on the other way, there is a concern that you are using what are given to you, right? So it is somewhere it is not customizable. And certain again, it is this statement differs as far as different deployment and service model that you are using. Security in cloud is always a big challenge, and that is a continuum feature that you need to look in, right? Because your data is on a common facility and you need to be careful. Just to give you an idea, you can look into this particular block of IBC that I just gone through just 3 4 days before. It is of February 10, 23. It says that though there is a hype as far as cloud computing is concerned, but there are three harmful mistakes that companies are making in cloud computing: cost management, right? And it says that as far as conclusion is concerned, it says that don't just lift and shift your workloads to the public cloud just because of public cloud is in a trend. That should we do. We should have a agreement with the cloud provider and shift our business from this normal IT resources to the cloud. No, it's not like that, right? We have to be careful for that. Cloud management requires new practices, but of course, it's a technology. A new technology, there are a number of dimensions to it. To better utilize, you need to understand all of this. Cloud expertise should not just be left to the specific teams because the better you understand cloud, more benefits we take out from this. Otherwise, lastly, to conclude, what we have that with the help of clouds, we can reduce the capex. But if the things in clouds are not used properly, we can result into very high OPEX and the things are not balanced. So it is not a blind game kind of thing, blind done kind of thing. We have to very judicious as far as uh, clouds are concerned. All right. Anything else that I have? Yeah. Okay. I've collected certain bibliographic references for you people just to share. This are getting just to an idea where are the current research heading on. So if we just see fog of things, it is again edge computing current trends के लिए जैसे बात की थी तो cloud computing में current trends edge के fog, right? So these things are gone. This is a very good read. If you're interested, you can have a look into this to understand the topic. Uh, then the multi-cloud applications, it is giving you the trend towards or the complexities of multi-clouds. So again, you can read this book, read this paper if you want to have more idea into it. Energy efficiency, because this is always a predominant feature of whatever field you go for, either this is wireless sensor network, IoT, or whatever data sets and whatever machine you are working upon. Always there is a thrust on using the energy efficiency. So this particular paper is very good read as far as applying energy efficient techniques as far as cloud computing is concerned. Then comes this dynamic resource allocation because this is on-demand provisioning of resources. So we are having different kind of algorithms, techniques, protocols as far as this dynamic resource allocation. This paper is an effort to compile certain strategies. If I'm not wrong, it is somewhat more than 100 papers of literature that is reviewed and collected just to give you this paper. So it's again very good read as far as this dynamic resource allocation in cloud computing is concerned. Lastly, cloud forensics in security is also one of the major field of research as far as computing is concerned. This particular paper provides you a comprehensive study as far as cloud performance is concerned. I think with this, I just finish my discussion or interaction with you all. So this is thank you from my side. Over to you, sir.
Okay, thank you, sir.
Thank you.
I request the participant to please put your queries with our expert. Participant, if you have any query related to the topic of cloud computing, kindly put your questions. Otherwise, you can directly mail to the question to our honorable speaker, Professor Bisal, sir.
Yeah, if you want to mail anything to me, I will try to the best of my ability to resolve that on my part. And my mail ID is vishal.gupta@nsut.ac.in.
Okay, so the mail ID of sir is bisal.gupta at the rate nsuit.edu.
nsut.ac.in.
.ac.in. Okay.
Okay, so I think there is no question from
Okay. 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 So thank
side.
you, sir.
Thank you. Thank you
Okay.
very
So
much
thank you,
for
sir.
inviting
On
me.
the behalf of the organizing committee, I will put the vote of thanks for placing very nice talk on cloud. Nicely, you have covered the brief introduction, various services provider, including benefits and the application of cloud computing and the architecture models and different platforms that are involved in cloud computing. And nicely, sir, you have covered the utilization of clouds and Kubernetes topics. So I think these topics definitely enhance the technical as well as research skill of our participant. So once again, thank you, sir, for spare your valuable time with IIMT University Meerut. And
Thank you.
thank you very much, sir.
Thank you. And it's all good day to all. Thank you. Thank you very much.
Thank you, sir. So I request all the participants kindly leave this meeting. The meeting is